All right, are we ready?
You're all good.
Okay. All right, so today we're going to jump into Megachile. We started a little bit last time, but now we're going to officially start parsing through Mike's key. As first of all, I get to learn some of Mike's identification guides. A lot of them are paralleled in the Discover Life app, and we're going to, reflect back and forth between them. We'll start with the females and move into the males. I've got pretty good specimen selection here in the lab, so I think we'll be able to run with that. So I'm going to share my computer, and then we're going to jump to the key, and we'll talk about a couple things here first. So Mike splits his key at the beginning, and it takes a little while to sort of get the hang of this, and which is he separates the parallel-sided species from the not parallel-sided species. So this is referring to the abdomen, kind of like Ceratina. So with Ceratina, the abdomen is like I think of it as almost like a water bottle, ribbed, but relatively parallel-sided. So within the Megachile females, and the males to some extent too, but particularly the females, you have specimens that are the tergites are at least say 1 through 4 are about the same distance. This is the problem. It's an about thing. So after a bit, you know it when you see it, but it's a little bit difficult to quantify. So we'll see a whole series of parallel-sided things here to begin with to get your eyeball up. You can see them also when you can go through and look at iNaturalist or just Google up these pictures to get a sense of parallel, not parallel. But I'll keep coming back to that and we'll reflect on it. So the first specimen we're going to look at is pugnata. So again, Mike's keys goes off splitting out the two. Now we're going to jump right in here to the first of the parallel-sided ones. And we have a very distinct species, pugnata, and I've got it up on the scope already. And let's get it at full screen. Oops, that was the wrong combination. Control Alt Shift F in this weird scope thing. So here's a shot of the abdomen. Now, you, with a lot of experience, you could look at that and say that's parallel-sided, but the reality is, there is still this curve here going on, and the widest width tends to be about in the center of the longitudinal length of the abdomen, whereas in the non-parallel-sided species, you basically are going from relatively wide and tapering down to relatively narrow at the end. It's more of a triangular, I guess, type of thing, where the greatest width is much more towards the front of the abdomen. Again, we'll look at this as we go by. So pugnata is very distinct. It has very distinct character, which we're going to show here in a second, but it's also a large, very large Megachile, has kind of what they would call dark or infuscated wings. So you'll see them at this time of year. They love sunflowers and other things. And we're going to take a look, and the head is kind of big and broad, but it's the side of the head and the mandibles that are very distinct. And so I'm going to take off the label and we'll get into that. So it's not in the key per se, but if you look at the face, this pattern here of the oops, of the edge of the clypeus. So here's the clypeus is roughly here, and as is in several of the species of Megachile, but very dramatically so here, you have a lot of bumps, denticles, or tiny teeth or whatnot. So this pattern, this big broad one, and then a couple of these smaller ones, is relatively dramatic compared to almost all the other species. Additionally, you have a relatively dramatic mandible. So this mandible, it'll be as we turn the specimen, it will also be even more obvious. It sticks way out. It forms this really big set of choppers. There is a cutting tooth, and you'll see in Mike's key, he calls these cutting teeth cutting margins is probably a better name. We might convert to that in the DL guides too. So you have, and we'll see this over and over again. You have the teeth. So if we start way out here, it curves a lot. So tooth number 1, and so the counting system starts from the very outermost tooth, and it includes the tip of the mandible, which counts in our books as a tooth, as does the very rear of the mandible. So here's 1, 2. It's not easy to see the remainder here, 3, but there's 3, and there's probably a 4th one back there, but because the mandible's closed, you can't see it well, and it's dark. But you can see here this sinus, this emarginate area between tooth 2 and 3 over here, and then there's this thing. So this is why they're leaf cutters, right? So they have these cutting edges that are placed between the teeth in a variety of different patterns, and sometimes those patterns are extremely useful. So in pugnata, you have this big tooth here. We'll see all sorts of other ones. In some, basically the tooth or the cutting margin will lie between the 2 teeth there, and in a knife-like way. So big mandible, big head, big body, lots of stuff going on in the clypeus, but the gimme on this is the side of the head, but you do have to look at the side of the head to see it. And so sometimes if you're not immediately going, that might be pugnata, maybe I'll check for this projection on the cheek. It's a little bit difficult to see here, but okay, let's back up and pull the head down. And what we're looking at, so you can see from the side, first of all, here's the clypeus again, edge, and not only are there these small knobs or denticules, as you might call them, sticking out from the rim of the clypeus, but they also stick up. So again, pretty dramatic. And look at these are closed. So these mandibles, even when closed, are dramatically projecting. And the kicker, though, because no other species has this in the region, is you can look at the side of the head, which is quite wide. So this area here is wider than the eye. But down here, a little bit hidden in the hairs, as I'm trying to do 2 things at once. And we're going to see a projecting, protruding projection tooth, if you will. So this is actually the side of the face, and here is the tooth. I'm trying to show that it's hidden by some of these hairs. I'll flip it to the other side too. So several things. It's like Halictus legatus has this too. It's as if the head were made of clay and you pinched a piece and pulled it out. So you have this projecting, dull, tooth-like thing. Nothing else has that. So that would tell you right away it's pugnata. These things show up in trap nests fairly regularly too. Let's flip to the other side. Take a look at that. And we're seeing a number of characters here. So that shows it even more dramatically. So again, very wide cheek. This is extended and pulled out into this projecting horn-like tooth or projection, however you want. And that's going to tell you right away that that's pugnata. So wouldn't it be great if all species were like that? In a bit, we're going to talk about, because it's more characteristics, but in the Discover Life guides in particular, one of the best characters to look at is what's going on S6. So S6 has hairs on it, and there's patterns to the coloration, and there's patterns to the very tip, and there's patterns to the amount of hair, often with a bare spot in the middle. That, again, really helps separate out the species and can do that relatively quickly. All right, I'm putting Miss Pugnata back in her box, and we'll flip back to the key. We're looking at the key here again. So anyway, Pugnata just comes out all by itself. Then we're confronted with this thing here where we have the Clypeus with apical margin expanded as a broad flattened area perpendicular more or less to the basal port of the Clypeus, mandible length at least 3 times its basal width. So just really long mandibles. So we have the difficulty here is I have males of Sculpturalis and I have no rugifrons, but basically what you're seeing is a incredibly long and skinny mandibles that stick way out in front, much more so than Pugnata, which has pretty broad mandibles and comes together. Sculpturalis is a species. I'm going to show you a male. We'll dial back to this because the males and females look relatively similar in aspect. Very dark and very large species. So it's the giant resin bee. It takes over nests of Xylocopa species at times. And I'm actually at my lowest magnification here, and this is just simply a male. So it has this highly sculptured abdomen with humongous pits in it and very dark wings. And this is generally how the females look too, but they would have gigantic choppers, which we're not able to show here because I have no females. I gave away most of these to someone. Was it Catherine? Maybe. And the rugifrons, I don't have any specimens either. It's more of a Midwestern one. We see it very rarely in the area. I've only seen a few specimens, but if you look at the pictures, you'll see that the mandibles are not only skinny, but project way out, particularly rugifrons. So Mike is talking about here, Clypeus with the apical margin, so the very rim of the Clypeus, modified in a variety of ways, but not with this broad flattened area. So I believe that makes it look relatively flat-lipped, and his presents here for these two species, which again, sorry, I don't have them, as a almost a wall when you look at the Clypeus head on. But now we're going to jump down to the mandibles with and without cutting margins. So we referred to those previously, and there is only a small number of species of Megachile that don't have any cutting margins whatsoever. Mike's a proponent of opening up those mandibles when you have your specimens are freshly caught and not been in alcohol for very long, so that you can more easily look at the size and shape and dentition of mandibles for Megachile and for Osmia too, and other species. But you can, in many cases, see most, except for the very rearmost portion of the mandible. And sometimes you can see that in Megachile, even though the mandibles are closed. The one mandible, and we did a little study, it shows that bees close their mandibles in random fashion. So the left mandible is closed as is over the top of the right, just as often as the right is over the top of the left. Anyway, often in almost all cases, you can still see one of the cutting edges of one of the mandibles is open for inspection. You can see the teeth and the cutting margins. So in this case, we have a small set of species, maybe 5 or 6, that have no cutting margins between the teeth. And so many of those are parallel-sided in Mike's book, and we're going to pull out a couple here and talk about them. And then the remainder have some kind of cutting margin. So it might be a single cutting tooth, or it might be that the entire sinus is filled at a lower level with something that is used to help them cut out leaves. So jumping, because we're going to 6 without the cutting margins down there. And then in this group, you're looking at whether there are these little bead-like denticles or projections at the rim of the clypeus, similar to kind of what we saw on pugnata, or it's straight or nearly straight and doesn't have, or at minimum doesn't have tiny teeth. So if it is toothed, then you're down to 2 very common, I believe this is also the case in the Midwest, 2 species that we see regularly, including in the middle of the city, and they're, I believe both are resin-using species. And by resin-using, I means that they are using resin in the construction of their nests or the capping of their nests, rather than the more common, or the leaves, which makes a little sense, right? Why, if you're messing around with resin to cap your nests, then why do you need cutting margins? Because you're not cutting any leaves for any particular reason. So those have disappeared. We have exilis and campanulae, neither of which really, even though despite the name campanulae, they're really not specialists on campanulae. They can be found in lots and lots of places, including places that have no campanulae whatsoever. And both seem to be very regularly seen in our state. So I'll show you. So let's look at the clypeal margins here, and then we can look at the mandibles at the same time and look for the lack of cutting edges. So here we have a headshot of exilis, and we are going to zoom in. I'm not going to show you the parallel sides, but here's the tooth. Here's the teeth on the mandible, 1, 2, 3, 4 teeth. And then in between, you can see that, I don't know what that blob is, but there's no cutting tooth anywhere in this system. We'll go even a little bit further up, and you can see here that, I wonder what this thing does. Zoom. Oh, it has a little mini, oh, how interesting. Anyway, there's no tooth in there. Turn that off. Maybe point. So no cutting margin to cutting teeth between the points on the mandible. So that tells us we're in this set of very small number of bees, that probably all of which use resin. And oh, I should also point out, on the clypeal rim, again, we have in exilis, there should be a small tooth, and then sometimes there's additional teeth to either side. Small tooth in the middle of the clypeal rim, and some bead-like things to either side. And it's very difficult to see in this particular specimen what's going on there. But let me see if I can bend it a little bit over. Take it down to 2. Bring it over here. Bring down the lens. And hopefully we can see the edge of the clypeus. I think my specimen for campanulae is a little bit better, but oh, you can kind of see it here. So again, holding the specimen in your fingers and rotating it gets you the perspective that allows you to see some of these features better. But here's a clipial edge. These are mandibles, I believe, right there. And here is the small central point, and there's two side points in there as well. Not very big. So another feature, Mike doesn't mention this, but this is one that I use very regularly because a lot of times you see this group, campanulae versus exilis, and you have to figure out, well, what are they? So when we look at this, also this feature, which again you'll see in Discover Life, where you have the T6 rear end coming down and then flanges out, makes a hard turn. I'll show it from in profile so you can see that architecture a little bit better, is a distinctive feature of only a few species. The key point here is that T5, this is T5, is lined with a very thick and heavy, similar to the other ones, set of prone white hairs, making a little fascia along there. So it's complete. It's very noticeable. It's difficult to see. In campanulae, it's either absent or there's only bits and pieces of that, but mostly it's completely not there at all. So it's a pretty good feature to have in your bag of tricks for telling you apart.
And Sam, which of the two do you have up?
Exilis.
Yeah.
Okay, so here, Mike also, is that the species? I'm not sure. I think he mentioned something about these black hairs, but I want you to look at, here's this convex part of T6, and then this lip that turns out right at the edge, and that angle in that little lip and that sharp return on the specimen integument is illuminating. Let's look at Mike's key here again. He talks about the single tooth denticule in the middle of the clypeus. And then he also says T6 pubescence all dark, central and southern regions of the continent or of where his area. So here is the T6 again, and you can see all these hairs are darkened. And now, in contrast, there must be light hairs in campanulae. So let's go to campanulae now and take a look. Sort boxes. My specimen ready. So campanulae has also no cutting edges on the teeth, and we'll try and get the rim of the clypeus in here so it can be seen pretty easily. And what we're looking for is no central tooth, rather the center is bare and there are two teeth to either side of it. A lot going on in this specimen, but the two teeth there's one, and I think easier to see when you're manipulating the specimen yourself. There's one tooth there and one tooth there, and the very center where there'd be a tooth in an exilis is missing. You can see the mandible that's lapping over the other one here. 1, 2, 3, 4 teeth, and in between the sinuses of these teeth, there is no cutting margin at all because of their resin using lifestyle, apparently. And now if we pivot to the abdomen, we should see that the abdomen has little to no hair on the rim, at least not in the sense of the big bright white fascicle series. And so here you can see, I'll shift this around a little bit. Here's the abdomen. This is the last segment. Here's segment 5. And here, right here, is the rim of segment 5. And there's nothing there. But segment 4 has at least partially, a nice bright white set of hairs. I'm going to pivot this a little bit so we can see it better. So you can see here, T1, 2, 3, 4, 5, and this is 6. And there are, at least on the lateral sides, very thick, similar to exilis, bands of white hairs, but on T5, nothing. So I find that to be a very useful key. Mike also mentions that on the backside of the abdomen of T6, it's not all dark hairs. You can see white hairs, looks like intermixed with black hairs. Let's see if he says that. So clipial margin with 2 teeth, 2 little denticles, denticles, no, denticles, denticles, I guess. And T6 pubescence usually largely pale, so we saw a lot of that with intermixed darker hairs. So that's a good separation set of characters there. So now continuing on to things that have no cutting margins, but are associated with cutting margins on their teeth. They have cutting margins, rather, and they should not try and do 2 things at once and kill the ants that have invaded my desk. They have a margin of the clypeus that is not modified, or not modified very much. So get my clay out here. So we're going to look at Megachile georgica, relatively uncommon species, and I believe Mike notes too that it occurs southern half and more in the south. It's large, and we'll take a look at the head. It tends to have dark wings, not as quite as large as inimica and pugnata, but still fairly large beast.
Sam, we have the chat asking if both exilis and campanulae use resins to build nests.
Yes. Yes, they do. And so I don't know if, like, here's georgica. Georgica has no cutting teeth too. I don't know if they all use resin in that group, you know, because they don't have cutting teeth or not. Someone maybe knows that and can let us know. All right, I've lost track of the specimen. Here we go. So now, looking at the head, we'll shift to the clypeus edge, and we should not see, again, you have some hairs here, so it's a little bit less apparent, but there does not appear to be any teeth or other anything other than pretty much a straight rim. A little difficult to see there. If we zoom down to the mandibles and get that in focus, we see the teeth again here, and with nothing in between the tooth margins. So it is another one of these species that has no cutting margins. And now we're going to flip and talk about S6. So S6 is a important character in Discover Life because despite it being let's see, get back down here. Despite it being a, looking for my specimen in here. Despite it being not a place that people in other species groups look at a whole lot, it turns out it's really valuable and full of all kinds of discriminations of the good kind in, why is it going that way? In Megachile, in the females. Males, not really. So recall that Megachile carry their pollen underneath the abdomen, and that there are pollen-carrying hairs or scopal hairs throughout this area. I'm going to escape out and bump up the light a little bit here now. And so S6 is also underneath there. And I guess because of the adjacency of the sting and maybe other kinds of things such as forming the walls of the nest, perhaps, they have a bunch of different modifications. So I want to maybe take it up to there. Oh, that's the wrong direction. How about up like that? Okay, this is a little bit better. So we're at high magnification now. We're looking only at S6. So this area is the target when looking at almost any Megachile female you would want to flip over and take a quick look to see if it conforms to the species you think it is. So in this case, it's similar to what you might expect. It's all uniform. It's all dark. There's no central bare area. There's no difference between the fringe area and the basal parts of the hairs in terms of changes in hair color, or and there appears to be nothing going on right at the rim in terms of how the rim is formed. But we'll contrast that with motivaga, which is coming up next, which are quite different looking one, but just happens to key out here. And instead, we're going to now, so this is the underside. And we're going to flip this specimen and take a look at T6 on the opposite side, and a character that I use most of the time for georgica and is in the Discover Life guides. Got to find the specimen. Here it is. Right here is, I may have to change the orientation, but is the fact, we'll change it to the side here, is that there are white hairs here towards the base, and then there are upright dark hairs towards the very far end. So let's take a look at this from the side. And similar to the campanulae exilis crowd, probably because they're related, the lateral sides of the very end of the segment has that little, I call it a flange, sticking out of the tip. That's pretty distinctive, paralleling the group. You can also see S6 there. Bring this over. So here's this pattern where you have these white hairs towards the base and then darker hairs to the top, and you have this turn out from where it's concave, and then it becomes quickly as this flange that runs around the rim, and it turns out at an angle. So that's again within Discover Life guides. Other species, this might be completely flat. Other species is just gradually concave. There's a few where it's gradually convex. Others where it's gradually concave. So what else does Mike have to say here? Surface of S6 strongly and densely punctate, so pitted. I think we saw that. I didn't point it out. It's also all dark. So he says S6 hair is dark. T6 covered with more or less erect hairs, but it doesn't mention the hair color, which I find to be useful. And sinus between first and, so sinus, that's the gap area between the outermost tooth, which is tooth 1, and the first tooth to the inside, broadly U-shaped, and we will see how that contrasts with motivaga in a second. So let me swap specimens here. Motivaga is just a very different looking beast altogether. Put all the tags back on and get it in the right box. Motivaga. All right, so let's look at the characters here. How are we doing on time, Claire?
You are A-okay. It's 1:35.
Okay. So he's contrasting that with a 6 surface. So we're going to take a look at that. Pale hairs, and it's bare in the middle. And he talks about this apical fringe. But basically, another way to think about it is that the central area is bare of hairs instead of being completely haired up. And also has pale hairs, not all black. So, and T6 has does not have the erect hairs that were present in georgica, nor that same color pattern. And he's saying the basal tooth of mandible little. So interesting. I'm not sure if we're not talking differently in terms of when I talk about the first tooth of a mandible, it's not towards the base, it's the tip. So I'll have to talk to Mike about when he talks about the basal, he says the first tooth, whether we're going in the opposite directions. We'll table that for now, and when Mike comes back, we'll talk to him. And we could look at the Motivaga specimen teeth thing for a while, but we have other species to look at. So let's take a look here. First, we'll take a look at T6, and you can even see the hairs on S6 as almost entirely pale there to begin with. So we have the similar flange where it's convex at the base and then flanged out very strongly at the tip. And when we look at the hairs here, we see that the hairs are mostly pale and they don't have that dark light pattern. Oops. That georgica had. All right, I gotta find the specimen again. Oh, I'm on the wrong side. There we go. So you don't see, in fact, you don't see many hairs at all. The fact that georgica, he talks about erect hairs, and that is true, but it's a little bit difficult to discern the two. But the easiest thing here is to, in addition to the fact that T6 does not have that pattern of hairs, is to look here at S6, which is very different from what we have in georgica. Although other species of bees have something similar, other species of Megachile have something similar of this pattern, which is it's almost entirely pale, and there is a dense, and I think pretty much all the Megachile have this, have a dense set of shorter hairs, maybe not even really scopal hairs. They're towards the tip. Apologies for the fiber that's in the way. Towards the end, so there's almost always this smaller, denser set of hairs that form a fringe in all the different species of Megachile. And then there are the scopal hairs or scopal-like hairs that are towards the base of T6. There's a little bit on T5 there too. And then this whole central area in the middle is bare of any hairs. So that is very different from what we saw in Megachile georgica. So easy one to key out if you're careful. So within Discover Life, you know, it's always important to not guess and to, and to score things conservatively, because you can always go back and change it and try a different pattern of scoring. Okay, so now, did I pull? Oh, I may not have pulled the frugalis. So now we're going away from this set that Mike had separated here based on lacking cutting margins. So we were looking at ones that didn't have cutting margins. So now we have parallel-sided things with cutting margins. And that first one gets us to frugalis, which is one that shows up here and there. It's a species I don't see a whole lot of. It may be more common to the west of me in the mountains than around town, but I found them several places now. So the distinct thing about frugalis, I believe this is in Mike's key too, is it's what I notice, is that on the clypeus are erect dark hairs. Let's see what Mike has to say here. So yeah, clypeus with long, dark, erect hairs. That's very unusual, maybe unique, and pale, shorter, suboppressed hairs between the dark hairs. The clypeus is relatively flat. Margin undulates without any, any teeth or bladder processes. And mandible usually with a small process or point between first and second teeth. I don't know what that means, but we'll take a look and see if we can find that, because normally in Discover Life you would key it out using the notion of the hairs and other features that you would have gone through, and having the dark hairs of the clypeus becomes your go-to. So here we go. Now if we zoom in, we can see this better. So here is mandibles here. We'll look for that small tooth thing. And here's the hairs. And you can see that there are both what he mentioned, which is upright dark hairs in the middle of the clypeus. And then below that are oppressed, which means basically prone or lying down hairs that are white and shorter than these other ones. But it's these dark upright hairs that make this stand out. And the edge of the rim here throughout this area undulates, looks like a little bit, but has nothing noticeable. So if we take a look now, let's see what this tooth, perhaps we can see that now. That was spoken about in Mike's key. That I'm just not aware of. Find the specimen again. There we go. Get that in focus. Okay, between first and second tooth, this might be a good opportunity to see what Mike considers the first and second tooth. The normal is 4, sometimes 5. Okay, so in my book, 1, 2, 3, 4, possibly in Mike's book is 1, 2, 3, 4, which is a little bit disturbing that we are counting in different directions. So, but Mike is probably the one who is following the proper procedures. So here, I believe, let's zoom in one more level, is probably this small mini tooth, if you will, between the basalmost tooth and the next tooth. Mike's 1 and 2, mine's my 3 and 4. Ugh. Okay. Anyway, it's hard to see that exactly, particularly with my crosshairs over it, but that seems to be the small tooth that he was speaking of. But again, this sort of short clipius, dark black hairs, I guess slightly flattened. It has a unique look to the face of the specimen. And well, let's take a look. It's theoretically, I don't know if that tiny tooth counts as a cutting margin, but let's see if we can quantify a cutting margin elsewhere on here, because that's the differentiation. You know, I don't know what's going on there. That could be a cutting margin, but not super obvious. Okay, so the mysterious frugalis, it's just appears in collections I see only uncommonly, goes into this box. And then we'll go back to Mike's key. And so we have the dark-haired ones. So these are species now that have teeth. And then we're going to look at two others here, inimica and Polycharis. So I have no Polycharis. I've seen that only once or twice, very southern. But I do have inimica, which shows up pretty rarely. Its aspect is very similar to pugnata, and also your first impression would be that it's the same thing. That one is the other, but obviously it doesn't have the tooth at the base of the front cheek that pugnata has. And Polycharis is just something I don't see a whole lot. I believe they look at some of the teeth characters here, but let's see what he says. So clipial margin weakly trilobed, and so meaning it's got, instead of teeth on the edge of the clipius, you'll have sort of weakly convex areas that look like lobes, but not, not strongly lobed. So we'll show that. And medial portion produced as a very broad, weak triangular lobe between the two small lateral tooth-like or lobe-like processes. So not, this is saying that it's more of an undulation rather than something very dramatic like some of the other species. And then the clipius weakly convex S5 hairs, all pale. All right, so let's just take a look here at S5 because it is such a, well, actually I have pollen all throughout the specimen, so maybe more difficult than I think. But S5 is such a lovely character, if you can find it. There we go. And yes, indeed, there is pollen all over. I wonder if it is sunflower pollen. I can't remember if it's a specialist on sunflowers or not, but it looks pretty suspicious. And so interestingly, I'd have to see what Discover Life does. So here's the fringe area, which is dark hairs, and the interior, though, is light hairs. We can flip over to Discover Life and see, because Mike says S5 hairs all pale. So again, Mike and I, when we compare our notes, sometimes we find out that there are differences in plumage, the plumage of the same bee species, or that we've just not correctly separated out two species out of something we think is just one species. So that seems to be not the case in this inimica. And but let's see what else we can do. Let's look at the, that's not the usual way we separate things out. I may have another inimica. We can also check that one too. Let's take a look at the clipial margins here.
And by the way, TGP, if you hadn't caught on, was tall grass prairie.
Oh,
what that
yes.
stands for.
Yeah. So Mike's keys are meant to be used in the tall grass prairies ecoregion, more or less, but they're broadly applicable throughout the east, and he brings in several species to the west of the Mississippi that we really don't get or hardly ever get to. So the range is comparable for, so you can use Mike's keys for almost anything, with the notion that if you're outside of his range, that you might be seeing something else that wasn't listed by Mike, but mostly he lists them all. So here is the Clypeus. Here's the rim of the Clypeus. Here's this weak, weak broad lobe in the middle. It's really just kind of a convex area. And then here's more tooth-like or lobe-like areas to the lateral sides on that. If you look at the mandibles, we should find a cutting edge or a cutting margin in there. There it is on that tooth, which is nicely spread out for us. Oops, did that a little too hard. Another, you can see how it looks like pugnata. Very impressive mandibles. Gosh, what did I just do? Should be coming back into view here. Oops, there we go. You can see the very dramatic cutting teeth here. There's one. This is on the other mandible, and I don't think there's any additional ones in the back. Those are, I believe, his characters in there. Let's take a look at one more, if I have it, just to see if in a specimen with less pollen all over it. Where's that one from? That's from PG County. That's where we are here at the Bee Lab. And move this away and take a look at, okay, here's one. This one is from West Virginia, and it's cleaner. It has less pollen on it, so it should be less confusing. We'll take a look at its S5. And oh, maybe there is a bunch of pollen in there too. I can see those pale, slightly orangish hairs. So often when we talk about hair color, we just talk about pale or dark. But within Megachile, several species have, some species have bright white pale hairs that are scopal hairs and long, and others have, where did the specimen go? There we go. And others have off-white, and others have clearly orange tinged hairs. And often that can be illuminating. So here you can see kind of the same thing. Oops. Which is, when we talk about and discover life keys, we're including what color the fringe is. So I just wanted to see if this pattern held up. So here, pale hairs at the base, and there are darker hairs around the perimeter fringe. So you have to be aware of that when you're looking at.
Sam, can you center that in the frame a little bit better?
Okay, it seems to be moving.
Yeah, it does. Thanks.
Okay, oops. Bring that up, and I'm going to tip it a little bit more so we can see that fringe. But this is really a go-to character in identification of, bring this way down, identification of Megachile. All right, so here, So this is pulled out quite a bit. So normally this would be retracted under there. But you can see there are pale hairs right here. Those appear to be very similar to these. They have an orangish tinge too. And then there's a dark hair apical fringe. So I'll have to mention that to Mike. Because indeed his inimicas may have only pale hairs, or he may be simply not counting the fringe. I'm not sure. This is the problem with definitions sometimes. All right, I know we're approaching our time. Let's see if we're, yeah, so this might be a good stopping point, but I'll think I'll contrast the parallel-sided things with non-parallel-sided ones. Also show you Xylocopoides because it's such a another gimme specimen, and talk about parallel, not parallel-sided, and then if there's any questions, we can discuss those. Here we go. Okay, so what we're looking at, first of all, is an incredibly dark bee. So this would be the darkest Megachile. I see them mostly on composites, and zooming around there, and just jet black. And it's very easy to spot in the field. Okay, so there we go. And we'll bring this back down, but we'll just look at the abdomen shape, not parallel-sided in this particular case. And you can see that the greatest width is well to the away from the tip, let's call it, and it has this broadly tapering aspect to it. So the problem is that when we talk about things like parallel-sided, then it's like kind of parallel-sided, because nothing is exactly parallel-sided in nature, right? There's always going to be some departure from that, a very exact definition. And this is the problem when we talk about, let's say, Mallar spaces or something else being equal. Equal is would be very rigidly defined. It has to be exactly the same on the top and the bottom. And what we mean is roughly equal in most places. So roughly parallel-sided versus clearly not parallel-sided in these cases. So the next set of species, which we'll cover next time, are going to have this taper shape with the greatest width clearly offset from the middle towards the base. And this lovely creature here is our friend Xylocopoides. It's been moving north. It's one of the few things, because it's so noticeable, people will catch it. Yeah.
Sam, real quick, before you go too far into identifying Xylocopoides, Laurel had a question.
Okay.
Hello, good afternoon. Thank you. In his key, is this the starting point or below Xylocopoides? Are the rest of the species non-parallel sided?
Correct.
Tapering?
Yep.
So we could say this is kind of the dividing line.
Yeah.
Xylocopoides.
Yeah. So if you look at so I've thrown back onto screen the key, and so a person who does their keys well, which Mike does, their dichotomous keys, has where the previous, so if we're at couplet 11, it also has in brackets, sometimes it's a slightly different format, but basically they also say, well, the place that you ended up, that you came from, was the first couplet. Okay, so often it's a useful guide path through keys is to look at which couplet you have. As you get more and more advanced in thinking about species and things, you might go like, well, I think I'm looking at a xylocapoides. So you would jump in a dichotomous key, would jump right to xylocapoides and then backtrack through the key as the quick way to come up with your answer. So here, for example, you would go, okay, it's xylocapoides. I can read that. Yes, that sounds good. Let's go to the next one, which is 11. Okay, so there I am at 11, and I'm going to look at where I came from, which was this character here pointing me to 12, and I could agree or disagree. And so you can reverse engineer guides in a useful way once you have some ideas, like you have a hypothesis, like it's, oh, it is xylocapoides. And rather than slog through the whole guide, you could jump right to that species and just verify by using the guide path that a good guide person would leave. So here we can see, for example, that this 11, which would go to either 12 or 13. So in 12, we ended up with xylocapoides and pruina, which we're not going to talk about now. But before that, it goes to 1, and that's the character here, parallel-sided, not parallel-sided, essentially. So does that make sense?
I have to look through it slowly. Thank you.
Yeah. No, it is a lot
help.
to
Thank you
take
very
in
much.
sometimes. And it's a very different, like if you've mostly been using Discover Life keys, then this is a very different approach.
Yes.
It's hard to jump. So people have most people come in from a dichotomous key background, and when they go to Discover Life, they apply their dichotomous key mind, which is I have to answer the first question in order to go to this next question. And it's very different, obviously, in
Kind of
Discover Life.
linear thinking instead of matrix thinking.
Yeah. So, yeah, sometimes there's transitional issues, but here we have both keys available to add a lot of interest to our lives.
Thank you very much.
Very tiny bee lives. So I think that's a good stopping place there, because the next set of species would all be similar in that they are parallel-sided and probably have a lot of, and do have a lot of taxonomic similarities. And plus we're approaching, if not beyond, our time limit. Any other questions?
I think that's all from the chat, at least. You're welcome to unmute, or we can wrap it up.
Okay. Yeah, here's xylocapoides again. Basically, every piece of this specimen is jet black and really, spectacularly obvious when it's going around on top of these composites, rubbing its hinders all over the place. So it's a pretty cool bee.
All right. Well, great job, everybody.
Okay.
I'm gonna stop the recording now.
Oh, and Claire, you had mentioned that probably we're gonna, because a lot of people are in the field, that we're probably going to do the bumblebee talks in the fall.
Yeah. We have one lined up and more to come.
Yeah.
All right.
All right. Thanks, everyone.
Bye.
Thanks, Claire.